Alright, so let's do example for power for test for proportion. Okay, so let's consider the hypothesis test that the null hypothesis is p smaller p less than or equal to 0.5, and the alternate hypothesis is p greater than 0.5. Sample size n is equal to 100, and alpha significance level alpha default 0.05. And let's choose the alternate distribution is p equal to 0.6, which is greater than 0.5. Alright, so we have enough to calculate our power. It's a little different from before. So the null distribution, so using the central limit theorem, the mean is 0.5, coming from the 0.5 here. The variance is 0.5 times 1 minus 0.5 over 100. Sample size is 100. So this is, the mean is 0.5, the standard deviation is 0.05. And the alternate distribution has mean 0.6 and variance is 0.6 times 1 minus 0.6 over 100. This is equal to mean still 0.6, and the standard deviation turned out to be 0.049. This is not too far. Okay, and let's draw the two distributions. Okay, so to calculate the power, first we find a critical number or a critical point. Critical point is the one that gives you the z-value, because alpha is 0.05, so the z-value for the null distribution has to be 1.645. So the value is 0.5 plus 1.645 times the standard deviation, which is 0.05. This is equal to 0.58225. So that's our critical point. So this is the critical point. And we want to calculate the area to the under the rejection region. So we want to know the area of this part. So we need to calculate the z-score of the critical point under the alternate distribution. So the z-score is 0.58225 minus 0.6 over 0.049. So this is equal to negative 0.36. And if you look up the table, negative 0.36 area to the right is 0.64406. So this is our power. Okay, so let's keep the same data. So this is the same, pretty much the same example. So same null hypothesis, p is less than equal to 0.5. Each one is p is greater than 0.5. The alternate distribution is mu equal to 0.6. Alpha is still 0.05. But now we want to solve how big the sample size has to be so that the power is 0.8. So we want the power to be 0.9, sorry. Let's get it wrong, 0.9. Alright, so we can still draw the distributions. So the null distribution has mean 0.5 coming from here. The variance is 0.5 times 1 minus 0.5 over n. This time n is unknown. And the alternate distribution it has a mean 0.6 coming from here, and the variance is 0.6 times 1 minus 0.6 over n. Okay. So quickly calculating this, this gives us standard deviation is 0.5 over root n, and the other one, the standard deviation is root 0.24 over root n. Okay, so we want to solve n so that the power is 0.9, so let's do this. So the critical point, because alpha is 0.05, so that means the critical point has the z-score, blue z-score under a node distribution equal to 1.645. And because the power is 0.9, so that means the critical point gives you the red z-score under the alternate distribution. The z-score has to equal to negative 1.28. This is negative 0.1. And this is z sub 0.05. Both of them from the table. So, and let's recall the calculated z-score. The blue z-score is the, let's call this x. Let's call critical point x. Then the blue z-score is x minus 0.5 over 0.5 over root n. The red z-score is x minus 0.6 over root 0.24 over root n. So if we simplify a little bit, this tells you that x equals to 0.5 plus 1.645 times 0.5 over root n. The second one tells you x is 0.6 minus 1.28 times root 0.49, root 0.24 over root n. And because these are both x's, so these two numbers are the same. So we solve 0.5 plus 1.645 times 0.5 over root n equals to 0.6 minus 1.28 times root 0.24 over root n. And this is the equation, equation with single variable n. You can solve with a calculator. So we get root n should equal to 14.495, which tells you that n is 210.125 something. You round up, so n has to be equal at least 211. So this is our answer. Alright, so that's it for chapter 6.